Hello, everyone. Thank you so much for joining us for today's webinar. Today's webinar is titled Security in a Cloud-Native World, Infrastructure Trends, Security Challenges, and Best Practices. As we wait for our last few attendees to join, we'd like to run through a few quick housekeeping notes. First of all, the slides from today's presentation are available via the BrightTalk console under the Attachments section. There's also a handful of other resources that you might be interested in if you'd like to download those as a takeaway from today's presentation. Additionally, the recording will be shared soon after the webinar is completed. And finally, we welcome you to ask questions at any time during the webinar via the BrightTalk console. And we hope to get our speakers to as many of those as we can before the webinar concludes. I'm thrilled to introduce today's speakers, both from Twistlock and 451 Research. I'd like to introduce Fernando Montenegro, a senior analyst on the information security team at 451 Research. He's based in Toronto and has broad experience in security architecture, particularly network security for enterprise environments. He currently focuses on covering vendors and industry events in the endpoint security and cloud security spaces. Fernando, welcome to today's webinar.
Thank you very much. Looking forward to this.
I'm also glad to introduce John Morello, the Chief Technology Officer here at Twistlock. As CTO, John leads work with strategic customers and partners and drives the product roadmap. Prior to Twistlock, John was the CISO of Albemarle, a Fortune 500 global chemical company. And before that, John spent 14 years at Microsoft in both Microsoft consulting services and product teams. John, welcome to today's webinar.
Hey, looking forward to it.
Great. And now I'm glad to pass the ball over to Fernando to kick things off.
Thank you very much, Keith and John. Thank you very much, everyone, for taking the time to attend the session. I hope you'll appreciate some of the data information we're sharing. As Keith mentioned, my name is Fernando Montenegro. I'm based out of Toronto. I'm originally Brazilian. Which is interesting, if nothing else, because I just survived yet another Canadian winter. And I do look after these specific areas, endpoint security, cloud infrastructure, container and cloud native security is something I'm deeply involved in, following the market in detail, as well as a couple of other areas such as deception. I've been in this field for a while, usually in practitioner roles, both in terms of pre-sales and post-sales delivery. And I am very interested not only in the technical aspect of how cloud-native and containers technologies are affecting security, but the economics aspect as well. I mean, we are making changes to how organizations are thinking, and I think that is particularly relevant. Also, I like to be on Twitter as much as possible, so you can follow me there if you're so inclined. Now, I wanted to offer my perspective as an analyst, and I would just like to position where that perspective is coming from. So here at 451 Research, we do lots of research on different areas of security and other topics. What you're hearing about, or the comments I'm going to be presenting, they are based on two large pillars of methodology. Number one is the briefings, inquiries, and research. I talk hundreds of hours with folks in enterprise IT, with service providers, with vendors, and people involved in mergers and acquisitions, and we generate tons of qualitative research that then that is used, consumed by a number of ways. And then the other side of the table is the Voice of the Enterprise program that we run. Some of you may be familiar with it, and it's a rather rigorous survey program where on a quarterly basis we are reaching out to hundreds, if not thousands, of different security professionals and IT professionals, and then gathering their insights for each specific topic. Now, some of you on the call may actually have responded to those surveys in the past, so for that, thank you very much. If you're interested, hit me up and we can, I can get you connected to the right folks. One point I wanted to make is that as an analyst, I think that the best contribution I can make is not so much to drive the point about specific concepts, but more than anything else is to share with you what we are seeing out in the market in terms of trends. I like data visualizations a lot, so be prepared for a few charts along the way. So getting started, one of the first things that we wanted to point out is what does the nature of cloud delivery look like, both now and moving forward. So what we did here is we surveyed general IT practitioners, not just security professionals. And we asked them, the question is subtle, but we asked them where do they think the majority of workloads are currently running and where do they think it's going to run. This is not about asking what percentage of workloads are going to be running in each environment. The data here is what percentage of people responded that the majority of their workloads runs in a particular environment. And what you can see here is that, for example, on-premises traditional IT, in 2018, 46% of people responded the majority of things were going to be in traditional. That dropped to 21% as they projected to 2020. So I think that this data is very interesting to drive 2 points. First of all, we all know that cloud adoption is a thing, but how is that a thing? So where do we grow? And I just plotted out some of the data here. We saw a drop of 54% here. We saw an increase in private cloud, so private cloud is very much going to be a factor. Colo, we saw some increase as well. And public cloud saw a significant increase in terms of respondents. And one of the things I broke down is what do we see between SaaS and IaaS and PaaS. And the number of people who responded that they expect the majority of their workloads to be in public cloud environments was significant. So that was one point I wanted to talk about. But at the same point, I don't want to lose sight of the bigger picture, which is even though we are talking about cloud migrations from about cloud adoption, the overall trend for IT is to adopt a hybrid architecture, right? So people are moving towards, as the slide says here, moving towards a hybrid IT environment that leverages on-premises and cloud hosted. And I think that this is important. I mean, I love the cloud as much as the next person, but the reality for most organizations is a need to secure both on-premises and cloud. Now, some of the underlying data that we have here points us as well that, for example, if you look at the people who respond, cloud is not an important part of our IT strategy. Out of those, the average was 13%. But some of these track really well with how the company sees itself in terms of risk appetite and technology adoption. And just as a data point, 41% of people who self-identify their companies as not being technology forward, if you will, 41% said that cloud was not an important part of their strategy. So I think that even for the people who say the cloud is not important, only 41% of them are really not doing anything about it. So that's yet another point. Now, what does that look like? And here, I'll present a different chart. Here is what technology choices for people that are currently deploying on cloud. And this was, again, data not from security practitioners, but data from general IT. This is where the industry is going. And what we see here is that two things. I highlighted both containers and serverless compute, which are both very popular as choices. We can talk more about those if need be. But the other thing I wanted to point out here is that people are adopting different features from cloud providers in as they adopt cloud. You see very high adoption of database as a service. You see very high adoption of analytics frameworks and other features. So I guess the broader point here is that cloud is going to look a lot different. It already looks a lot different, and it's going to continue to look a lot different than just your traditional lift and shift. Okay. moving on to just highlighting that point. So this is what the current features are. Here's where people expect to be. So again, we see a high adoption of things like machine learning, and I'll pick on machine learning later on. But the broader point here is that as people are adopting IaaS and to some extent PaaS features, containers and services are indeed some of the very popular choices for adoption. We drill down into that. We drill down into that a little bit, trying to understand why. What's going on? Why are you doing this? And one of the interesting answers we got was that what really works well with containers and what really works well to some extent with serverless, though in a smaller fashion, is that when people were trying to design something, they were, the top answer here you can see is that they were designing software that's going to run native in any cloud environment. Now, this does not mean that it's running on multiple cloud environments at any point in time, but it means that there is the portability. This is how people are addressing the lock-in factor. Everyone is concerned about whether it's real or perceived. We can have that conversation, but people are concerned about cloud lock-in, and the way that organizations have responded to that is by, okay, we're going to write to a format that can run effectively on any cloud environment. And as you can imagine, this is where something like containers fits particularly well. This is where Kubernetes has been very successful in providing that level playing field. And we expect to see the adoption of things like service meshes to also play to that some of that as well. Now, not everything in the world is roses. So what are people? Why are they? What typically holds back adoption? And as you might suspect, security is one of those areas. So a number of customers, and what holds them back? Security is their key concern. I find it interesting that you can look at the other two the reasons, number 2 and 3. You have compliance and you have data protection, which are arguably within the remit of security solutions as well. So we absolutely see this almost psychological holdup to security being a key concern for cloud environments. One of the other kind of random data points I had that I wanted to comment on is you see cost at 22%. Okay, that's fine. It's interesting that when you break down the respondents, again, by how they are aligned with technology transformation, people who self-identify as being more conservative, actually not even conservative, people who are actually laggards or who self-identify as laggards on technology adoption, they say that to them cost is a priority, right, at over 30%, I think. So what this means is that the reality is if you're not adopting cloud, cost is a concern to you. Other organizations are concerned about security and want to see something done about that. Well, which leads me to another data point. So security is important. Security is a concern. Is it actually a blocker? And this is a chart. I'll talk a little bit about this chart because we literally just got the data a few days ago, which is what are the trends around data that's being hosted? How are clouds actually being used? And what's fascinating here, at least to me, is that when you look at on a yearly trend, right? We asked people, how do they think that cloud should be used? Is it just low-risk applications? Is it high mission critical? We don't know, or we don't use cloud at all. The two things I wanted to call out here is, first of all, people saying that they do not use cloud has been declining. But the other one is this one. the number of people who respond that cloud-hosted can be, or cloud-hosted environments can be used specifically or even including high-risk mission-critical applications. And up until these numbers came along, up until the 2018 numbers came along, it was a very nice upward curve. We see a little bit of a drop there. I'm still digging into what that data translates to, but I had a couple of other data points that I thought were relevant. One of them is when you break that down by the people who respond, again, how they are early adopters versus pragmatic versus conservative versus skeptical about technology adoption, that number, that 35% number jumps up to 66%. So what it means is that if you are a technology, if you are an early adopter of technology, you are comfortable around embracing cloud delivery even for high security applications, right? So it's a very clear data point. It's something that I think it's important for organizations to consider. The other data point is a little more interesting, or is that we also track who responded to the question, right? And the data on this one is that the notion that cloud can be used for high security, for high risk mission critical applications has at the highest level of support from senior management, believe it or not. So what it means is that senior management is confident that organizations can use cloud even for high risk applications. What that translates to down at the managerial, down at the operations level, down at the architecture level, is that it's going to be even harder, if it isn't hard already, it's going to be even harder to justify adopting technology that is not cloud-based on grounds of security. So the point I want to make is that if you are a security professional, using security as a justification for not going to cloud, first of all, it's something that is broadly on the decline. Then it is something that early adopters don't subscribe to. And also, importantly, it's something that senior management is not necessarily aligned with. So keep that in mind when you are moving ahead on your plans. Now, I wanted to bring up, I don't have the way of concepts, but I do have one chart I wanted to talk about, which is this. Let's say and this is a trend I've seen happen in many conversations. Let's say that you are the CIO for an organization, or you are the cloud architect, and someone comes to you saying, hey, we need to do some computing in the cloud. People often talk about where do we fit with, okay, we're going to spin up a VM. By my count, VMs are not your first choice on doing that level of generic compute. So let's walk through some of those. Depending on the use case, you might be talking about a generic machine learning use case. So this is where you would pick up Vision API, or you would pick up text processing, or you would pick up sentiment analysis. So you can use those APIs rather than instantiating the whole thing yourself. Okay, let's say it's not one of those use cases. Let's say it's a more generic machine learning case. Fine, you can use a machine learning service, right? Whether that be SageMaker or AutoML or Azure ML, doesn't matter, right? You can instantiate your models there. If it's not that kind of service, well, then you have the option of using a more generic service API. This is where I'm throwing in the hosted databases. This is whether that is Spanner, or whether that's Cosmos DB, or any of the 14 different databases that AWS supports. Well, okay, it's not any of those. Then maybe what you might want to do then is, okay, you're still more likely to try to implement that as a function, whether that be Lambda or Azure functions or Google functions, or any of the newer frameworks that are coming around supporting different functions. You'll try to run that as a function. Going down stack, you have, okay, then if you really can't do it as a function, can you do it as a container? Okay, if we're going to do it as a container, can I do it as an on-demand container? By on-demand, I mean things are spinning up without necessarily caring about the underlying cluster. And so that would be either, at some extent, GKE, that might be Azure Container Instances, or more popularly, that might be AWS Fargate. Keeping going down stack, you have, okay, fine, we have to spin up a Kubernetes cluster. Fine, we'll do that. But even that's still a newer technology stack. Lastly, if you can't be a Kubernetes cluster, can we spin it up as a templated app? I'm thinking here of Beanstalk and to some extent CloudFormation. And then only finally would you necessarily go down the route of VMs. I love my VMs as much as the next person, but what this chart shows you is that for modern cloud workloads, it's really down in your options as something you need to, as something that you would deploy initially on. Doesn't mean you don't have to service them. By all means, they do, but it means that it may not be your primary choice for compute. And the consequence here is that on one hand, you're abstracting away the compute, makes it higher value, faster time to value. On the downside is degrees of portability. And you'll find that containers and serverless are kind of a very nice middle tier between them. I want to wrap up just touching on a couple of cloud trends. Number one is, again, we expect hybrid to be the pattern for most enterprises. The workloads will continue to be a variety of virtual machines, containers, and others. We didn't touch on it so much in terms of data points, but we do see a lot of demand for automation, particularly in the context of skills gap. This is more on the security side. And then finally, security remains a key concern. With that, I just want to thank you for listening to me. I'll pass it over to John now. Again, if you want to reach out to me, either you can reach out on Twitter or other things. With that, John, please take it away.
Thanks, Fernando. So we're going to build on the topics that Fernando was just talking about, or at least the trends that he's identified in terms of the market and this general sort of move and just acceptance of the notion of private cloud and cloud first, but also the notion of it being a hybrid world, and that no longer do you really have a situation where customers are saying that we're never going to go to cloud or that we're going to put absolutely everything in cloud, but instead that we're going to have this mixture of scenarios. And I want to talk a little bit about what's driving some of this cloud adoption first, and then what are the kind of the security trends that impact that as people go and think about the risks that are present that Fernando was alluding to as one of the primary concerns, how do those risks really map to this technology space, and what can you do to mitigate them? So there's I think, two real trends that are driving the way that, at least at Twistlock, that we think about security and cloud native security. And those two trends, the two kind of things that are colliding with each other. The first one is this notion of software eating the world. You know, every organization is developing software. It's no longer something that's just a tech company thing, but people that, you know, work in manufacturing or government or financial services. Software is a core competency that people have to develop to be able to differentiate themselves from their competitors. And because of that, you have to have the tooling that enables you to iterate rapidly on that software that you build. And by and large, that tooling is basically what we consider to be cloud native. It's a set of technologies from containers to serverless and this whole notion of DevOps and integration with CI/CD flows. That ability for your developers to ship a new version or an update to an application in hours versus, you know, weeks or months, that's one of the things that's driving so many organizations to adopt this new operating model. At the same time, you have this notion of the world, you know, continuing to be a dangerous place, and I would argue in a lot of ways becoming actually even more dangerous from a software standpoint, because as you start seeing more and more usage of these patterns and more organizations providing more services over the internet to their constituents and their customers and business partners, the potential targets for attackers continues to grow. Like, there's more stuff that's out there. Also, those same tools that enable organizations to build software more rapidly and to scale it out on a planetary basis also allow the bad guys to do their thing on a very scaled out global basis as well. So it's not, you know, like with most technology, it's neither good nor evil. It's an amoral technology that can be used in a lot of different ways, and the attackers have access to the same kind of tools, the same kind of cloud services, and thus can really do their thing at scale in a way that really wasn't as feasible just a few years ago. The other bullet that we have on here, I think it's an important thing to consider, is in most cases, the software that you create inside of your own organization is often the softest target in the entire stack that you run. In other words, you're running on Amazon and you're running Kubernetes and Docker, or maybe you're running on Fargate or you're on GCP or whatever it may be. There's a whole lot of layers to that stack, from the physical data center to the hypervisors to the OS that you're running on and the container runtime and so forth. If you think about the security of that stack, it's far more likely that the compromise is going to come at the application layer, because the application is the thing that's actually exposed out there to the internet at large. But also the application layer is typically the place where you see the most amount of vulnerabilities. If you're building an application on Node or Java or Ruby or something like that, the typical way that people build these applications is by leveraging a lot of existing open source frameworks, things that help build connections to databases or display components. And all of those technologies tend to have significant amounts of vulnerability. They need to be updated over time. Developers find problems and correct them. But if you're building enterprise software on that, it's not necessarily easy for you to identify and understand what those things are so that you can address them quickly. So those two kind of compound forces, this drive for everybody to become cloud native, to meet that goal of software competency, and at the same time the fact that the world is becoming more dangerous because of those capabilities being accessible to attackers, and because the software that you're running in a lot of cases may have some deeply seated vulnerabilities. Those two things collide and really provide a serious challenge for people to be able to overcome. It's not all bad. I mean, there are some things that cloud native makes more difficult, and it's useful to think about this, I think, from a higher level standpoint, a more academic standpoint, not about Docker or Kubernetes, but just this whole notion of rapid software iteration and cloud native infrastructure. What, from a characteristic standpoint, makes doing security harder in this world? And there's really a few things I think that are critical to understand there. One of them is the fact that everything is ephemeral and everything is constantly changing. And what I mean by that is, think about your traditional application pattern where you are running a virtual machine, an application that you installed on VMs. In a lot of cases, you might deploy that VM today, or you might have your developers build their app and they tell an operations team to deploy a VM to support it. That team deploys that VM, and that thing is going to run for a long time. You're going to assign it some IP address or DNS name, and for most organizations, those VMs are not going to turn over on a frequent basis. You're going to build and deploy the app, and you're going to run it for months, years, for a significant amount of time. With cloud native, one of the things with containers and serverless is that they're much more ephemeral. The containers are going to come and go based on application updates, but also based on characteristics of your load and demand. And so because of that, there's a lot greater degree of change within your environment than it would be if you're talking about a more static, sort of classical environment. Additionally, there's just more things that you have to manage. That traditional application that you might have run, like a 3-tiered app that you run on VMs, where maybe you have, 2 app presentation tier, 2 app tier, and 2 data tier, for example, VMs. If you decompose that and run that in microservices, you might suddenly end up having hundreds or at least dozens of microservices that comprise that same application, depending on how far you do that decomposition. And so not only are the things changing, but there's a lot more of those that you have to deal with. And then finally, I think that one of the things that's maybe least obvious but very critical is the fact that security is very much in the hands of the developer. If you think about traditional operating patterns in the classical world, you often would have a development team that would build an app and then hand that off to an operations team who would install the app and be responsible for installing updates to it. You install the particular version of the JRE in production, and 2 weeks later you run a tool like some sort of vulnerability management tool, and you see that JRE version has a vulnerability. Well, the operations team is going to go and update that version of the JRE, right? With cloud native, because you're packaging everything in these container images, in many cases it's up to the developers themselves to fix that application. And while that's not necessarily a bad thing for the developer to fix it, it's a different pattern than what most organizations are traditionally familiar with. And because of that, it can be challenging to be able to basically convert your environment and your operational processes to be able to manage that. But it's not all bad news. There's some things that Cloud Native really presents as an opportunity to do things much better than you've been able to do in the past. If you think about Cloud Native, one of the fundamental characteristics of it is this notion of of having a consistent artifact from development to test to production, right? And so one of the things that consistent artifact makes possible is the ability for you to really integrate security in a consistent way throughout the life cycle of that application. Historically, again, to get back to that example of maybe a developer building some Java app and deploying it, with the help of the operations team, historically you might have a different, in fact, almost certainly had a different tool for looking for vulnerabilities in development versus looking for vulnerabilities in production. Those tools didn't talk to each other. There was not an easy way for the operations team to signal back to the development team that, there's a vulnerability in something that they had run. And so because of that, it's oftentimes difficult to be able to complete the loop, to basically tell the developer, hey, this thing that you're running out there in production needs to be updated. Because you have that consistent artifact, you've got the ability to flow it all the way through and to be able to apply a consistent security policy throughout. And the characteristics that make that really possible is the fact that containers are a very minimalistic technology. Containers and serverless for that matter, there's a lot less bits inside of a container image than there is inside of a virtual machine, right? So just the fact that you're talking about a container image that might be, tens or maybe 100 megs versus a full-blown virtual machine image that might be, dozens of gigabytes, the ability for you to understand that reliably via software is much greater with a container image because there's just a lot less stuff that you have to deal with. Similarly, that stuff is described in a much more declarative manner. You're able to actually look at that Docker image and see that it's built from layers, and those layers are described in the Docker file, and you can really understand the composition of the artifact. You can't really do that with VMs, right? There's no way to look at a VMDK, for example, and really be able to ascertain exactly how it was constructed. And then finally, the fact that they're very predictable at runtime. The notion that you're going to do the same thing from the beginning of that container's life cycle until the end, and it shouldn't vary. Containers are not general purpose compute instances. They're focused on a specific thing, and because of that, you can build software that can model what is normal and look for anomalies and prevent those anomalies without you having to create static and manual rules to control all that. And that set of capabilities, one of the things that's really interesting and it drives a lot of this adoption is the fact that you have a lot of different infrastructure options for running these containers and cloud-native services. You can go from VMs to containers to the CAS platforms, serverless. They're all interrelated. And while they're all different compute capabilities, they're all kind of focused around this notion of really being application-centric and providing a high degree of decoupling and separation between the application that you're running, the underlying compute infrastructure that was there. So, much as in days past you had virtualization like Hyper-V and VMware that, decoupled the OS from the physical hardware, and then you had cloud that kind of decoupled, the virtual machine from the physical data center where it ran. What you're talking about with cloud native is basically decoupling the actual application from the OS. And that allows you to have a greater degree of agility of where you run that and the ability to be able to move that stuff around in ways that you haven't historically been able to really do. And that creates both that opportunity to improve your security portfolio and to rapidly iterate on that, but it also introduces some risk from a security standpoint. There have been some real world risk. I've never been somebody who focused on trying to create a lot of kind of fear and uncertainty about containers. Containers are no more or less secure than hypervisors were. They provide a different kind of tool set. That tool set is focused on a different kind of scenario. There's some things that containers do really great. There's some things where they provide less isolation than others. But the point of this slide is not to emphasize the fact that containers are dangerous or inherently insecure or anything like that, but that instead there's now, because of this usage of containers and this broad adoption of cloud native, much as has always happened, the attackers are going to follow the adoption curve. If you see a whole lot of people that suddenly start running on Kubernetes, if you're an attacker, you're probably going to spend more time looking for vulnerabilities in that stack so that you can understand how you can attack people that have moved to that stack. And that's one of the things we've really seen over really about the past 18 months now is there's been a lot more focus in the research community and just the black hat community as well on finding vulnerabilities in that stack and figuring out ways that you can pattern attacks toward these cloud native architectures. So how do you protect cloud workloads across that kind of continuum of options? The first thing I'd like to talk about is this notion of compute options really being a continuum. You can see on this slide here, you have this kind of, lever from left to right. And on the far left side, you've got virtual machines. On the far right side, you've got serverless. And the attributes that you see on the far ends of those levers really are defining like the strengths on each side of those levers. So, virtual machines really provide a high degree of isolation and control and compatibility, whereas serverless really emphasizes density and agility and the fact that you don't have to worry about the host OS. And with this continuum, what you're really providing within your organization is the ability to put the fulcrum on that continuum wherever you might need it for a given workflow, or for a given workload, rather. So if you have some workload that's a legacy workload and it's not really suited for containers, it's very monolithic sort of application, or maybe you've got very specific configuration requirements, you're probably going to put that fulcrum further to the left, right? You're going to run that on a VM so that you've got that compatibility and that control to do that. Alternatively, if you're building a really simplistic application and you don't want to have to worry about anything, you just simply want it to run whenever it's needed, but not have to manage any kind of infrastructure under it, you're going to move that fulcrum much further to the right. You're going to have a scenario in which you're going to be really prioritizing that agility and the simplicity of the application and not have to worry about the underlying compute infrastructure. And so the idea of this continuum is that you've got this set of options, and depending on what a given workload needs, you can move that fulcrum from one side to the other to give you the best balance of capabilities for that particular scenario. And this is not something that an organization typically does on a global basis. Most people are not going to say, I'm going to run everything in VMs, or I'm going to run nothing in containers, for example. You're going to choose the right workload or the right continuum option for the right workload. And most organizations are going to have a mix of those, which is one of the reasons why having a consistent security policy and a tool that can manage across all those different deployment options, from those VMs to containers to serverless, is so important, because you don't want to have bifurcated or siloed kinds of security technologies for managing each one of these options, right? You wouldn't want to say that because I choose to run something on a VM, I now have to have a totally different approach to security for that environment and completely siloed knowledge and alerts and so forth than I would if I just happen to run that same workload in a container. Having a unified platform gives you the ability to be much more efficient in the way that you secure that environment. So let's talk about each one of these scenarios briefly. VMs, again, remember that's on the left side of that lever, which means it's prioritizing isolation and compatibility and control. From a security standpoint, the stuff that's important there is the ability to be able to understand how that host OS is configured, to be able to have the ability to see vulnerabilities in it, to be able to check for the compliance and configuration of that. But also there's some scenarios for hosts that are typically pretty relevant from the traditional world as you move those applications into a VM that you might be running within your cloud provider. They don't go away. Like file integrity monitoring is probably still something that you need to be able to have. You probably still need some kind of forensic capability such that if there's a compromise, you can understand what transpired with it. And so one of the things that's important with virtual machines is to not just do things the way that you've done in the past, but as you move those VMs into a cloud-native sort of environment, to be able to give those same capabilities you've had in the past, but to layer on some new ones that allow you to operate that in a more agile way. Because most organizations that are going to be successful in transitioning those VMs are not simply going to run them in the same manner that they did when they were running in their own data center. If you're going to really get that value of this cloud-native approach, you need to be able to manage the VM almost like that cattle and pet analogy, in the sense that you're no longer going to manage each VM as its own special entity and configure it by hand and have its own personality change over time as you reconfigure it. Instead, if you're running that VM in a quote-unquote cloud-native manner, you're going to deploy with automation like Terraform or CloudFormation templates, and you're going to manage the configuration of it through Chef and Puppet and tools like that. And you're not going to care if one of those VMs fails. The thing you care about is the app. And so you have to have a security approach that's not really worried about that specific instance of the VM, but it's designed to manage security of VMs at scale instead. Containers are something that has become increasingly relevant, as you heard from Fernando's conversation earlier. With containers, you again have that ability that we talked about at the beginning of my section here to really do security in a much more automated and efficient manner, because you can now leverage those characteristics of cloud native, that minimalization, the declarative nature of it, the predictability at runtime, to be able to do security more efficiently than you could in the past. And so the security platform that you have for that needs to be able to take advantage of that. It needs to be able to automatically model what's normal in your application and prevent those things that are seen as abnormal. It needs to be able to give you a consistent security policy from development to test to production. And it needs to be able to signal all the way back such that when you find something in production, you're able to not just send an alert to your SOC, but actually tell your developer, hey, this app that you deployed yesterday that was fine, today there's been a new vulnerability discovered in this component that you use, and you need to rebuild that image and redeploy it to correct that vulnerability. That ability to have that full signal all the way from production back to development is one of the key attributes of a cloud-native security platform. Containers as a service and this notion of on-demand containers is something we've seen become a lot more popular in the past year or so. These are platforms like Azure Container Instances and AWS Fargate. It's just kind of an in-between notch between containers and serverless on that continuum, where you're saying that we like the ability to run containers. I like this, the flexibility and kind of the portability of containers, but maybe I don't want to have to worry about running the underlying container runtime infrastructure. So these CAS platforms basically abstract that from you. You just give the platform an image and it runs it for you. But what you're trading off there is some of the control and some of the portability, right? If you build something that's very optimized for AWS Fargate, while the images themselves you could take and run elsewhere, the whole deployment pattern, the way that you monitor and do logging and so forth is going to become much more kind of sticky to that AWS platform. That's not necessarily a bad thing, but it's just one of the trade-offs that you have to keep in mind as you do it. And again, because there's this desire and move to be able to be flexible in how you deploy it. You may have some workloads that are better suited to containers that you run in OpenShift, for example, on Amazon, others that you prefer to run in Fargate. You, again, want to have a security platform that spans all that. And one of the key things with this container as a service scenario is that you want to be able to provide that without locking yourself into one platform or another. Most organizations we see are being intentionally multi-cloud. They're saying, like, I don't want to just be Amazon or just be Azure. I want to use 2 or more public cloud providers so I have some leverage and some flexibility. I'm not locked into a particular provider. And then serverless is kind of the notch that's furthest to the right on that lever. Serverless is really all about the maximum amount of agility and simplicity. And so what you trade off with that is any sort of control of that underlying host OS. And so for a security platform to be able to effectively secure serverless, you have to be able to provide that runtime security in a different way. Instead of being something where you're running as kind of a peer of that function, like as an agent, so to speak, within the host OS, what you have to do now is embed security within that function. So one of the things that we focused on at Twistlock is to make that embedding approach as simple as possible. We don't want you to have to mix together the application that you built and put the security tool inside the app with the developer configuring it and controlling it and so forth. Instead, the way that we do it is you build your function just as you always have. You give that function to Twistlock either via the API or part of the CI flow or even via the UI, and then we return to you a protected version of that. So, we do all the work to do that embedding, and we keep all the security configuration logic in the security team's hands, so the developers can't override that. An attacker that gets somehow into that function can't change that configuration, and that allows us again to have that consistent security platform from development all the way into production with the ability to signal back and say, this function that you're running today, this function was just discovered to have a vulnerability in Python, and so you need to build a new version of that function to address that vulnerability. So that entire life cycle from development all the way into production, to be able to tell the developers when there's things that need to be updated, that's one of the key aspects, not just for containers, but also for serverless here. So the approach that we take is really, again, as you might imagine, trying to give you that platform that covers that entire continuum from host to containers to serverless, and stresses that lifecycle notion that I've talked about a few times, to be able to not just provide visibility in an isolated manner across all those environments, to be able to provide control and enforcement and a complete ability to kind of signal back from one place to another what happened within production and how development teams need to update their processes or build new versions of images to address that. So the focus we have is kind of across 2 axes. One of them is kind of the compute options. Where on the continuum do you want to be? We want to give you coverage across all those places: VMs, containers, serverless, CAS platforms, everything you saw on that continuum lever, we're able to cover you on. Similarly, throughout that life cycle, from the time that your developers are building the app, to the time that they give it to test, to the time that it's pushed to a registry or a serverless repo, to when it's running in production. You don't need to have different tools to address those different parts of the life cycle. Having a unified platform allows you to have a much greater degree of control and visibility, as well as automation for sending that security intelligence back upstream further left in the life cycle. And so the platform, we have really kind of three main pillars that we do. Automation is one of them, which is all about that notion of that automatic learning as enabled by those three characteristics of containers and serverless, the ability to know what's in there, that declarative nature, the minimalism of them, the predictability. So automation to do the learning, not just of what happens inside of the function or the container, but also how does it talk to other entities over the network. Visibility is about not just giving you a kind of a static list of the things that are wrong within your environment, but giving you a contextual understanding of them so that we're able to give you this basically Google map of your environment that really is almost like a live video that shows you all the containers, the hosts, the serverless functions. It color codes them by the compliance or vulnerability state. It shows you how they connect to each other. And it does that automatically by continuously learning about the environment and continuously updating it as you deploy new aspects of it. And that visibility and that contextual understanding is a really important aspect to being able to deal with that rapidly changing and ephemeral nature of containers and serverless. And then finally, prevention, that the ability to leverage that predictable nature of containers and serverless at runtime provides you ability to do actual prevention in a manner that I think has been unachievable with traditional systems. In traditional systems, you basically always have these kind of block lists, manually configured lists of malware signatures or IP addresses that, were looked at as being bad or malicious. We have that. It's kind of a baseline piece of what we do, but the real core value that we provide is learning what is normal and then automatically stopping just anything else that's abnormal. So if you have a container image that's supposed to run a web server, for example, you don't have to create a rule with Twistlock that says don't allow it to run Netcat or don't allow it to listen on port 25 or something like that. We automatically learn that it's supposed to run Nginx and it's supposed to listen on port 80 and it's supposed to write to this particular file path, and then automatically anything that's outside of those bounds is automatically prevented and blocked. Not based on some static signature list of everything that's bad, but instead based on the fact that we know what's normal and anything that's not normal is just automatically prevented. The capabilities we provide across that life cycle that deliver on this promise is basically the ones you see at the bottom there. It's vulnerability management, again, integrated from beginning to the life cycle. Compliance, which is basically the implementation of hundreds of different checks covering the CIS benchmarks for Docker, for Kubernetes, for Linux. Cloud native firewalling, which are a layer 2 and a layer 3 and a layer 4 firewall, specifically designed for these very ephemeral cloud native environments in which IP addresses really don't matter. You want to define firewall rules as saying like from this image to that image, regardless of what IP address it might have at any given point in time. Runtime defense, which is that preventative aspect to be able to learn what's normal and block those things that are abnormal. Access control, which is a whole set of capabilities we have for looking for anomalies in Kubernetes audit logs and integrating with secrets management tools that you have so that you can securely integrate your existing enterprise IT systems for authentication and secrets management and authorization into Twistlock and into your container environment. And then finally, the CI/CD integration is the ability for you to integrate with tools like Jenkins or Bamboo or Circle CI to be able to deliver those vulnerability management and compliance features all the way at the beginning of the life cycle of your application. So that's a quick overview of this notion of the continuum of cloud-native apps and how security is different there, and then how we try to solve for that in Twistlock. So with that, Keith, I'll turn it back to you.
Great. I just want to take a second here while people might be writing in some questions. We have about 10 or so minutes reserved for that to thank both Fernando and John for leading today's presentation. And I want to kick things off here on the question side with a question from the audience. What are some good resources that you would recommend for people to learn more about these cloud-centric technologies? First, Fernando, and then John.
First of all, thank you for the question. It was set up as a very nice question because I'll say that some of John's writings were some of the finest writings I saw on the topic as I was ramping up on it. So a while back, he wrote something about the continuum of compute that I thought was excellent. So look up on his blog for that. That was awesome. in general, the way that I think about cloud computing is I'm a huge fan of sites like edX or Coursera for that kind of content. There are a number of cloud-centric courses on there, and then it can really vary, right? Do you want to go more the development side? Do you want to go more on IT operations? Do you want to do security for those? I think it varies, but my recommendation would be take a look at both Coursera.org and edX.org for some of those courses they offer. And then the providers themselves have a ton of material, whether it be Google, AWS, Microsoft Azure, IBM, and others. They do have tons of course material that's particularly relevant. So I'd say think about what it is you want to achieve and then go from there. Right? I think that there's an edX course on cloud native technology that was really interesting. Okay. Hello?
Yeah, John, are you still there?
Yeah, I am. I really don't have anything to add to what Fernando said. I think his overview was pretty solid, honestly. There's a lot of data that's out there from the various providers, and there's plenty of stuff that's in the open source as well. I guess one thing I might add to that is there's a lot of good content that's available on more maybe developer-focused sites. There's a particularly good site that I've recommended to people before called Katacoda, which has a really great sort of learning playground that's available directly in the browser for actually using tools like Docker and Kubernetes and so forth with minimal setup, and they've got some really good self-paced labs that you can go through. So Katacoda is another really good place to do some learning.
Absolutely.
Great. We have definitely a question on a hot topic for both John and Fernando. Where do you see the service mesh and Istio fitting into the cloud native continuum, and how should an organization consider using Istio or a service mesh?
Well, we've actually seen a lot of people recently ask about service mesh. I think there's I want to say a lot of hype about it, because hype sort of has a negative connotation. But there's a lot of interest. There's a lot of talk about it right now. Service meshes are really designed to provide an additional layer of abstraction for networking traffic, particularly like ingress and egress, above what Kubernetes provides for just kind of connecting containers to themselves and to each other. Service mesh, I think, there's a lot of potential there. However, it's not the kind of thing that I would encourage people to necessarily, jump into right off the bat. If you don't have really a lot of experience with containers and Kubernetes and so forth today, you definitely want to kind of build up from the bottom floor when you think about composing your stack. You want to understand containers and that aspect of the world and Kubernetes and how orchestration works. If you find that those capabilities are not sufficient for your application needs, then service meshes can provide some capabilities to make it easier to network and connect those components to each other. However, at the same time, I would tell you that I think that a lot of the features that you see in stuff like Istio is really more tuned to operating things that are kind of like global scale, or at least like very large scale public-facing services. So if you're if you're an organization that runs like a user-facing e-commerce site or something like that, perhaps it would be useful. For most organizations, I think, like most typical enterprises, it probably is not something that you necessarily need to do today. And I think that those capabilities that something like Istio provides, particularly around like mutual TLS and so forth, I think will eventually make their way into standard features within Kubernetes versus being something additional and separate that you have to run.
I could not agree more. The comment I'll add is that where Istio or the service meshes play an interesting part is the idea that they are giving you extra observability of your traffic, and so in some cases it might play a factor if you don't have if you don't have that kind of visibility now, and you have multiple disparate teams and you're trying to deal with that problem at scale. Then it may play a part there, but I could not agree with John more in that, please, it's a walk before you run kind of thing, and you can probably get a lot done. By the time you get to look at service mesh, having looked at Kubernetes and containers before, you'll know exactly where it fits. Very good on observability and some levels of security, but it's really something a little bit far out for most organizations.
Great. It's really helpful. We have a couple minutes here, so I'll ask one final question to you both. With security largely in the hands or developers being a key part of securing cloud-native applications, how do you see enterprise infrastructure and security teams working with developers?
John, you want to go first?
I would say, yeah, sure. I mean, I think that the organizations that I've seen be most successful with that are the ones that realize that both sides have to evolve the way they've historically been operating. A lot of times security teams kind of look at developers as not being their problem. They really weren't involved with that stuff. Like the developer would create something, they'd scan it and just, say this passed or didn't pass. Whereas if you really want to get the most out of this whole approach to developing software on a more iterative basis and taking advantage of what cloud native provides, you've got to have a much closer relationship between what the security team does and what the development team does. Like those guys should literally work together, and the security team should be looking for ways to optimize getting developers information about vulnerabilities in a more rapid way, a more self-service way. And similarly, developers should be looking to figure out, how do I build my images and my applications in a manner that makes it easier to secure, that doesn't bloat an image with unnecessary components, that really properly decomposes everything, where when you're creating a new Kubernetes application, you're using a network policy to limit the traffic flows within it. So I think that the organizations that have had the most success with this are the ones that realize that security needs to move a little bit to the left for development, and development needs to think a little bit more towards the right, closer to security. And it doesn't necessarily mean that they have to all be in the same team and report to the same person, but they need to have a much more common mindset that it's a shared problem and work closer together. Historically, that's been, in many cases, unfortunately, an area of dysfunction in a lot of organizations.
I tend to agree. I would say that just picking up on that a little bit, I think that the way they work better together is for each, a little empathy goes a long way, right? So developers should really be made aware of the types of concerns that security teams have to deal with. I don't mean necessarily talking about FUD and attacks and whatnot, but what are the kind of security challenges that their applications are likely to have to meet, whether that be from a threat modeling perspective or whether it be from a compliance angle. So it's about security, about development teams learning what security is going to need for their application, and for security teams to understand better how developers are holding those functionality and how do developers actually work. Nobody expects a PDF of 100 pages of a vulnerability assessment thrown into their lap and say, go fix this. It doesn't work like that. You absolutely need to integrate with the CI/CD pipeline in terms of when you do the scans. You also should be able to provide guidance to them, whether that's in IDE type of coding guidance or whether that is something a little less automated, but you have to be able to provide the right information to them at the right time, right? But as I like to say, I think that a little empathy goes a long way in both cases.
Great. Well, we're just coming up here on the end of the hour. I want to thank both Fernando Montenegro and John Morello for leading today's presentation. And on the audience side, thank you so much for joining us. And I hope you'll provide feedback and rate this webinar so we can continue to provide you with what we hope is really good, engaging content as we navigate this cloud-native world. We did receive one final question, and yes, the webinar will be recorded and available to you after today's presentation ends. And again, thank you so much to our speakers and audience. Have a great day.
Bye, right.
Y'all have a good one. Bye.